Okay, let's begin with question number 9. So given that a and x are positive integers greater than or equal to 2, it's given like that. If a to the power of x is congruent to a minus 2 mod f a minus 1, find the value of a. Okay, this is quite an interesting modulo. And okay, I'm going to use a purely modulo solution. And use the other way of writing it out. It's an equation and then playing around. Since they wrote it like that, so I'll use a modulo style. So we replace a as a minus 1 plus 1 in the bracket like that. And then here I also replace the a minus 2 as a minus 1 minus 1. And then the modulo that we are evaluating in is a minus 1 like that. Okay, what does all this mean? Please take note. So I'm going to put it like this, congruent like that, just changing the color so it's a bit easier to see what is the modulo thing. So I'm actually basically rewriting all of this so that the a minus 1 part becomes a little bit more clear, a more thorough thing. So you can see the mod a minus 1 like that. If it helps, okay, the mod a minus 1 means whatever that is a minus 1, because see, the modulo trick is one of the tricks now. Is that a use the fact that, let's use the fact that a minus 1 is congruent to 0 mod a minus 1. Okay, sounds weird now, but that's what it means, okay? Because it leaves a remainder of 0 when divided by a minus 1. So whatever that is a minus 1 now, we can replace it with 0. That's what it means in a modulo arithmetic. Sometimes modulo arithmetic has been called the higher arithmetic, because it speaks in terms of remainders of numbers and all that. Just giving out some of the standard terms used in mathematics for this. So let's try this first. So in the bracket now, this becomes 1 to the power of x, which slowly a bit. It's congruent to negative 1 mod a minus 1. So then we can just use the normal algebra law. This is 1 is congruent to negative 1 mod a minus 1. When you bring it to the left, 1 plus 1 congruent to 0 mod a minus 1. So I'm just doing it slowly so that it's just like normal equation, right? Yep, most of the laws is the same except for division. Okay, and we'll take some what do you say, deeper discussion that time talk about that. So 2 is congruent to 0 mod a minus 1 means 2 leaves a remainder, good to go for the basic definition, a few equivalent definitions sometimes. 2 leaves a remainder of 0, okay, when divided by a minus 1. That means 2, or we can say it as, what's the other way of saying this? 2 is a multiple of a minus 1, not the other way around. 2 is a multiple of a minus 1. That means 2 equals, that means a minus 1. Another way in a reverse way to say, a minus 1 is a factor of 2. Can you see that? So I'm just purposely writing all this so that you'll know that these are like equivalent statements. Must know. So see, the factor of 2, there are only 2 factors. So either 1 or 2. That means now we arrive at the a minus 1 is 1 or 2. So solving it, a is either 1 plus 1 or 2 plus 1. That means in short, we are saying that a is 2 or 3 only. There are only 2 possibilities. Okay, so a is 2 or 3 only. So find the value of a. Why can't it be a modulo of a is 2? Because if a is 2, if you notice carefully, it's kind of weird to say in mode 1, right? That means, how do I say that? We put back a modulo of 2 to the power x is divisible by, I'm going to say, okay, let's say we put that back here at the top there. If a is 2, let's put it here. Equals to 2. And then you have 2 to the power of x. Is congruent to 2 minus 2 is 0. So mod of 1, 2 minus 1. Modulo 1 is basically divide by 1, get remainder 0. 2 to the power x gets remainder 0. So it's true for any x. So it's no real meaning to that. Like, we don't talk about mode 1, like, in other words. Okay, and it doesn't make sense. So that is why we're skipping that. Or you can actually put it as a solution. So since they seem to say a singular value, so I would skip that. Not to say it's wrong. Mode 1, that means anything divided by 1 going to get remainder of 0, of course, any number also. So any x can use for that. That's one possible solution. But by the context, I think they want only 3. So the answer is 3. So let's just have a look at what 3 would be if this was substituted. So 2 to the power of x would be congruent to 3 minus 2 is 1. And then here we would have mode 3 minus 1 is 2. Okay. Okay, so 3 minus 2 is 1. Am I writing correctly? Sorry, I wrote this wrong. It sounded weird. 3 to the power of x, sorry. 3 to the power of x. A is 3, 1, not 2. Okay, 3 to the power of x is congruent to 3 minus 2 is 1. Mode 3 minus 1 is 2. Correct. So an odd number gives a remainder of 1 when divided by 2. Yep, it satisfies perfectly. So that's the answer is 3, yeah, under the context. Thank you.